Right, everyone, time for the next.
Time for the next.
So, modelling and simulating human development. Michael's going to tell us about that, and has an hour starting from now. So.
Thank you. Well, I'm going to try and follow Anton's request to leave a significant amount of time for questions. I'm also going to give you a rest from the heavy mathematics. My idea is that the concepts are important, not necessarily the mathematical fiddling around. So I'm going to try and give you some stuff which is the result of several decades of work with my Mackie friend, Eric Durrell. He's an applied mathematician. I'm more of a generalist myself, and many years ago I got interested in the concept of information, although at the time I was employed by the information technology people, and this got me to be carved into a job which was absolutely magnificent, which is to be manager of a research project. Now I got a tremendous amount of freedom, and I was able to indulge in going to conferences like this and so on. I also joined the Scientific and Medical Network, and I indulged in some local networking in Geneva, Switzerland, where I live. So my role in this team of two was to bring together interesting ideas. What Eric and I finally decided to do was to do research which, had we at the time when we were gainfully employed, been able to do. In other words, no constraints, no money, no fooling around with grants, no political interference, no interference from the people who are allegedly going to take the results. And we wanted to do something important, something significant. Well, we live in the canton of Geneva, which has just recently got 500,000 souls, and this is dominated, what you might call intellectually, by CERN, shall we say the canonical physics community, and also the United Nations. Think of the United Nations as being the CERN, if you like, of the world of human beings and human development. So we've tried to bridge the two. What we did was we signed up with an organisation called the International Centre for Earth Simulation. This is a very grandiose project attempting to provide to people in important jobs a holistic picture of the society they're responsible for. A country, a city, a region, they don't really know, but what they do know is that the structure of knowledge is very fragmented and the boundaries are probably not very useful. So we decided to try and get them a framework. So our background, if you like, is modelling, and we decided, in the sense of being applied mathematicians and modellers and so on, that we would take advantage of all of the data which people had very conveniently done for us, as if they were doing the experiment. So we applied our theories to existing data. This is, if you like, an example of the big data situation. So what we did in the beginning, and this is talking about 10 or 15 years, is we accumulated like a toolkit of the things that we were interested in, And in 2012, we had a breakthrough. Because the United Nations is very interested in sustainability, and at the time there was a project with 8 sub-projects called the Millennium Development Goals. We proposed to the MBA program associated with the UN that we would model these, if you like, MDGs. We chose 2. One was to do with what at the time was a big fuss, which was the ozone layer was in danger of disappearing with very bad effects, particularly on Australians. And we were very fortunate in looking at this just at the time when there was data before the CFC problem, as they used to call it, and there was data after. And our modelling system allowed us to look at 2 things: what was happening technically and what was happening in the world of action and politics and stuff like that. And it turned out, fortuitously, that technology is invented to substitute for CFCs at the same time that the politicians said, you've got to stop doing this. People did stop doing this because it was cheaper, nothing to do with the politicians at all. Anyway, the result was, the model showed that the lifetime of the atmosphere was roughly 140 years. In other words, if we'd stopped on a particular day the atmosphere as it had been before humans had polluted the atmosphere with CFCs, it would have been 140 years before it recovered. Now this was a very interesting notion.
Is that the half-life?
It would take 140 years to go back to the original position.
So we're talking about 5 half-lives then.
So that was the first time that we really got excited. So what we tried to do, in a sense, was to look at data which existed, collected by humans, and feed this data into systems which we could handle. Now, unfortunately, the people that we speak to on the social side use long sentences and complicated words, and you can never get them to actually come down. This is, of course, the C.P. Snow situation where humanities and science, not only do they not respect each other, they don't actually listen to each other. So we got a guy, finally, who is interested in international relations, and we sat him down, we interrogated him. He used to be a friend of mine, now he's not. We pissed him off. and we eventually got him to agree to 4 or 5 words. So with this sort of background, let me proceed through these slides quite quickly. But I have one actual comment to add at the end, and that is, Eric and I presented to this ICES group last December, and there was an enormous amount of interest afterwards by a small number of people, and we have had the most exciting time the last 8 months. Now, like everybody else, Peter loves to talk about his latest stuff. I've brought some stuff that we've only been looking at and hasn't really been incorporated into our thought process yet. So if this time, when I start getting through my 26 slides or whatever, I'd like to introduce you to some other things. Because what Lou's been talking about, what Peter's been talking about, and what 2 other people have been talking about, seems to me, although it's coming from a weird direction, to be extremely relevant. So, I think Sam did a nice job the other day introducing a nice cartoon. So here's another cartoon. Because we are thinking about social systems as if they're alive, basically using the theory of evolution behind our stuff. Now I've modified the last line, it says, and then came ANPO or something like that, but total quality management. So, one period when we were working hard on modelling these Millennium Development Goals, we tried to find an analogy to how a country, say, or a city, might be managing itself. And it happened to be July, And those of you who are cyclists probably know that July is devoted to the Tour de France. And the Tour de France, or any large cycle race, is bunches of people. This year there were teams of 8 competing against each other. And yet somehow it's got physics involved, because if there are a bunch of people riding on a bike, the person in front has got 100% of the effort and the one behind is 70% and so on, even less. So there's cooperation and there's this and that, and then the wind blows sideways and so on. So we've decided that eventually we would like to solve this problem that this ICS Foundation have given us using the model of the Peloton. And that will probably require a topological quantum computing to sort it all out. So here's the basic steps we went through. We said, okay, we've got the economy, we've got society and stuff like that, and we settled on the idea that the economy and society work together in a way society advances because of the economy activity which feeds society and so on and so on. And the notion gets to be really, really complicated. It's just another version of the Peloton. And then we said to this guy who's no longer my friend, here is what we're going to do. We're going to look at the economy, which relates to this world of endowment. We're going to look at society, well-being, technology, which is capacity, and formation, which should be education, but we wanted to use the letter F, so it's called formation. And that is the social contract to increase the general, if you like, welfare of the people. This is our model, and despite the fact that I promised to be non-mathematical, here is actually the what did Lou say earlier on? This is the reaction diffusion equation in disguise. So if you interpret this with technical words, mathematical words relevant to the sort of things we've been talking about, then you've got volume, pressure, temperature, molecules, and stuff like that. On the other hand, it's also economy, education, society, and technology. In other words, almost like Peter's two universes, we're using the same mathematics to go from one to the other. So here's our toolkit. On the left, as I look at it, on the left as you look at it, I guess, there's an S-curve. And the S-curve, as far as we're concerned, has got 3 important things: the beginning, the end, and the inflection point. That's our basic notion. And when we look at data, which we have had nicely collected for us by other people, then we see that lots and lots of data is an evolutionary process, but it is comprising S-curves on S-curves on S-curves. One thing we looked at was the alleged cycle called the Kondratiev cycle. Kondratiev cycle has been written out by lots of people, including Kondratiev himself. Our modelling system said it's not only an economic cycle, it's not 54 years, and it's not even a cycle. We actually managed to include it into our algorithm, which we gradually developed by doing lots and lots of data sets using this sort of approach. One feature of this algorithm that was coming out was that it had in it some nerdy-like things, numbers which looked like we were going towards chaos theory. It also had an unspecified variable which looked like it was digitized and varied from 0 to 39. And we had it as a sort of time constant thing, and we discovered that if we plugged in the right value, we would actually get the Kondratiev cycle, and then the numbers next to the number for Kondratiev cycle gave us 2 or 3 other cycles which are well known in the world of people who study those things. So we then took another piece of work out of the world of social systems, the idea of Maslow and so on, and we interpreted it as a process. And here it is applied just to looking at things to do with agriculture and stuff like that. Now, there's a well-known notion for people who collect data. For example, in India, we've worked on some projects there where you wanted to know what people's income was, but they wouldn't tell you. But they would tell you how much they spent on food. It was a sort of proxy idea. So, by using that approach, we were able to use data which was around. And here we have the situation, and we actually found that one of the things we discovered was that Engel, a person called Engel, who invented some law which said that the number or amount of money that people spent on food, it sort of maximized, and then they moved on to education and stuff like that. So just by accident in our modeling, we rediscovered Engel's law. Another thing which was interesting was when we started looking over relatively long time periods, we looked at here the influence of technology and education. If you look at the lowest curve, this is the death rate, it's called survivorship, death rate, of people in the UK at a particular time. And then later on, there was a switch between the UK in the old period, 1650, to being much, much superior, if I like, in this case, to nuclear. And the reason we think was people began to understand vaccines, sewage, clean water and stuff like that. So the knowledge of society, how to deal with health, was very evident like this. Another one was we were dealing with these MDGs to do with things like child mortality. And by plotting the change over time of child mortality during the period that the MDG gurus wanted to study, the graphs, the data of course is always a bit rough, they all followed a very, very interesting series of patterns. So what happened then is that we investigated these things, and in the very recent past, something that Eric asked me not to talk about, is that we've now got into modelling the genome size and stuff like that, which I think other people in the room are very interested about.
What do you mean by genome size?
Okay, we'll come back to that, right?
Yeah.
So, I don't know if people are aware of this rather odd idea called the logistic map, but what we're saying after looking at many, many data sets is that the logistic map is like a single generator for all of the evolutionary processes ranging from the Big Bang to the history of the universe. And here, in a sense, we're connecting to chaos theory. We are taking the view that living systems evolve, 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 and life, in a certain sense, is on the edge of chaos all the time, and then comes back. So this is a little piece of software buried into this one slide, which probably needs a bit more explanation. So here we are, maybe on the edge of something which I promised, and that is to get a bit too mathy. So here is the idea of moving towards chaos. I don't know if anybody's ever studied the work of Feigenbaum and the ideas of period doubling and so on, but it's very predictable, and there are some numbers known as the Feigenbaum constants. And what we've done is look carefully at all this stuff and import the two numbers, which are known as alpha and delta, into our stuff. So what we've now got is the asymptotic slope for the things that we're going to talk about, and the scaling ratio, which is in effect an idea of time, are directly related to Feigenbaum's work. So here it is graphically. So there's an interesting slide. We're beginning to see on the side of on the legend there, the number of things which we've looked at, and the fact that the asymptote is actually delta to the half, and the other one is the ratio of alpha. So here we're going into lots and lots of data sets, and very, very quickly we realized that we should get very clear on what we were doing, and here's the notion that our holistic model of evolution needs its own equivalent, of the, if you like, the gutsy notions, and here it's explained, and there's the mathematics to do with it. And here we end up with what I find is the most interesting thing that we've stumbled over. We start to fully understand this. There's a thing we call the topic map, where the index here of k varies from 0 up to 39, and there appears to be a pairing between the lower and the upper. And we've painfully gone through most of the data sets, choosing them to be roughly at the timescales which the model predicts. So that's, if you like, where we got to when we were talking to this group in Geneva last December. We actually published all the references for all of these data sets. We published 20 questions, which were, people might have asked, why do you use S-curves? Why do you refer to Aristotle's causes and stuff like that? And then we asked for some help, which did come. And this was, how can we build process models maybe better? How can we simulate the behavior of the Peloton? Here's just a couple of things which we looked at. The modeling process is a bit strange because of the data, and we are not overly happy with just using, if you like, a single or limited vocabulary of S-curves and stuff like that. We tried to deal with the idea of chaos in a way. With this funny little model here, it's possible that the idea of period doubling is related to a version of this. So we're always looking for, if you like, some sort of physical explanations to what's going on. And Eric asked me to point out, Lou, that he's a big admirer of yours, and that one day we hope that this work will intersect with what you're doing. When we first fell over the interest in the reaction diffusion equation, we actually found it in some work in the financial world. But since then we've been dragged off to other equally interesting aspects. So the summary of the results is that we've got a process model. It is based on an idea of milestones. We thank all the people who've painfully collected lists of data about all the conflicts in the world, how long the human embryo takes to evolve and stuff like that, because we've just used them. They're all up on Wikipedia and sometimes more respectable sources of data. When we started this work, before 2010, this wasn't available. So we've been very lucky with the timing of starting to do this stuff. Now, just before I left Geneva a couple of weeks ago, we decided that we would mention an idea which we call historical field theory, which is, if you like, exactly stating the sort of stuff that the topic map reveals, but putting it forward as if it's a theoretical approach. So a physical field is, as we know, an historical field, just analogously, it's the same thing. We wanted to define the model. We had the model just now. We want to use the model to do human development, and we want the model to represent evolution of a particular subject. So that's where we got to with that equation, which I parked up the front of the presentation. And that is, as far as I'm concerned, the most significant result we've had. For those of you who think I went too quickly, here's the structure of the presentation. So if anybody has any questions, I'll be happy to answer. Thank you.
The Kondratiev waves.
Yeah.
We've got these sets of S curves. What are they? You know, because I noticed you had a green line that goes up and there, and then you had some of that line. Can I interpret that if the sum of the line is knowledge, that the horizontal lines indicate a paradigm shift in that knowledge, and that knowledge grows that way? You know, I didn't.
Kondratiev, like a lot of people, just collected a lot of data and he noticed patterns, right? And his database always the case, right? People who've got money, like governments, they have the money to find data sets, right? And he found these patterns and he said, blah, 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 54 years. And other people have then looked at it and they said, no, it's nothing to do with that, it's wood, coal, oil, nuclear power, you know, stuff like that. So what we've done in every case is we've said, we've got these ideas of milestones, we examine the data sets, and we find that they're usually sets of curves one on another. So we then can analyze these and we can carve them in our, if you like, emergent algorithm and say this is roughly 54 years. But if you move it around a little bit, it varies and so on and so on. So it's just an example of a data set. There's another data set called Juglar, another one with other funny Russian names and so on. But there's nothing special about it in the sense of what we're doing here.
Lou.
Lou, you had a question?
Yes, when you were writing the grades, if they are topological grades, then there would be some weaving over and under. Does over and under mean something in your chart?
No.
So it's just the way they interlace up and down.
That's right.
But would there possibly be a meaning in the system of weaving?
Yes, that's what we suspected, but we didn't get very good communication going with the people who are deeply into financial stuff, where this came to our notice. So we just noted it, and I particularly wanted you to know that it was somehow...
Do you have a notion of another variable that would correspond to the weaving?
I don't think Eric and I have ever talked very deeply about this, so I can't answer. Sorry.
Mark.
It looks to me like you're trying to articulate the dynamics of a social system.
Yeah.
Is that right? So, have you looked at the social systems theory literature? There's Nicholas Luhmann is the first person who springs to mind when we talk about this kind of thing. And there's been a lot of work in evolutionary economics, also, which looks at this. And there's also been a critical backlash against that kind of stuff.
Right.
I'm kind of interested as to what happened between you and your sociologist friend.
Okay. Here's a slightly longer version of the various conversations. His name is Daniel. Mike, I'm going to a conference next week, and I see on the agenda that somebody is giving a talk on quantum computing and international relations. Could you give me something to take along? So I went to see Eric, as I do every week, and we laughed about it, and we said, why don't we have a chat? And Danny and Eric's vocabulary doesn't overlap, so I'm in the middle trying to get these two talking. But when Danny came back, he said that there are lots of people investing in what you might call quantum-related activities, looking at, in this particular case, the theory, or the lack of new theories in international relations. And when we looked into it, in fact, there was a lot going on. But my experience with these people is that they use the word quantum, and it's sort of like you lift up the carpet and throw the word quantum underneath, put it down. So
Neuro is another one.
Yes, right. So there's nothing serious there. However, I did stretch the truth a bit. This guy, Danny, is still a friend of mine, and he sort of came back. And he is now very keen that we actually pursue this. And at the time when we feel comfortable, we give him some ammunition to take.
So, just to be precise about the nature of your problem, because it is important, is that we lack a meta-language. We lack a way of talking about the way we talk about these things.
Right. We, from the point of view what I mentioned, this ICES Foundation, they are looking to us to give them not a meta-language so much as a framework in which various theories of, let's say, how cities go, or rivers go, whatever it is, can actually somehow join in. Now, to elaborate a little bit on this foundation, the guy who runs it, his name is Bob Bishop. He's a bit of a, shall we say, a successful guy. At one time he was manager of Silicon Graphics and he made a lot of money. And he retired in 2005 and he got interested in two things. He decided in his retirement to do two things. One was to start up a project which is now called the Human Brain Project.
Oh yeah.
And that's 1.2 billion euros over 6 years.
Yeah.
So he got that going. And then he said, done that, now let's do the sustainability thing. And so he spends most of his time on that, 10% he keeps his eye on the human. So his idea is that this problem, expressed in my idea of the Peloton, is so complicated that it will mean lots and lots of computing. And my mental model of this guy, Bob Bishop, is that if you were to open him up, it would say high performance computing is good for you and even more high performance computing is better. So his goal is to solve massive problems with lots of computing power. And he's actually plugged into the quantum computing world and the other weird parts of computing and so on. And he's actually got a plan, which I partly helped him write, which is, big computing centre, probably not in Geneva because it's too expensive, 300 programmers rewriting all the code for various models and stuff like that. He's got a big issue there. That help you?
Yeah, it doesn't solve the CP Snow two cultures thing. We're still there, and what you do to deal with that, I don't know. I mean, my feeling is that the topic of information is very powerful for getting a discussion going between everybody. Okay, Nicola?
Mine was just, I lost somewhere. You say you've got the historic field and you went H and there were then like 5 letters and I totally lost what they were. So could you return, I think it was in one of the later slides, you talked about the historic field and you called it H with 5 variables, which were different letters. The last one was beta. I think the first one might have been EST something beta, but I can't remember what any of them were. Does this ring a bell?
Yeah, it was up twice, that particular
Yeah, I think
picture.
it was,
Yeah, the diffusion equation, I think.
Well, yeah.
Right.
Historical field, EST, I was pretty good, EST beta, and it's this F. So what are these in your terminology? Oh, right, okay, so E is event impact. S, event.
Well, I promise not to get too much into the mathy stuff, but there is a presentation here on this historical field idea, and here's the text. I can probably share this with you if you like, or anybody else is interested.
Lovely, yes,
I prefer that we have the other end of the questions, not the mathy stuff. I think your name is Roger, is that correct?
Yeah. Is this any connection to Isaac Asimov's science fiction idea called psychohistory?
Not to my knowledge. I mean, we've stolen stuff from all sorts of places, but I don't remember taking anything from...
Because I think the story was that the robots couldn't understand human behaviour, and so they came up with a theory, psychohistory, to predict what human behaviour was from as it goes on in history, from the past to the future.
But then Skynet went conscious, didn't it?
Sorry?
Then Skynet went conscious.
Well, that's the Terminator.
That's another film, isn't it?
The Terminator, but no, in the Asimov, the robots were trying to understand human behaviour. So they came up with a theory which sort of like predicted the crazy things people do all the time. Sort of like people do the same sort of history thing over and over again, repeating itself.
Yeah.
Yeah.
You had a question?
Observation. The unreasonable effectiveness of mathematics is one expression that comes to mind.
Yeah.
And you seem to have a universal mathematical model of social systems. So it seems to reach across the breadth of the human state, and it finds a model that matches most aspects of it.
I thought that the usual answer to that question was mathematics and physics co-evolved, so it's not a surprise that it's effective, right? But Mike, the filmmaker, and I had a sort of short discussion on the idea of meaning, and this question that you were asking, it is possible to imagine a meaning, if you like, of various acts of communication which are not based on the idea of information with respect to humans, but other entities in the living planet probably communicate and they have meaning, and the small hints come out are symbolic stuff and so on.
Elements of Gaia.
Sorry?
Elements of Gaia.
Yeah, absolutely.
I don't think that's conceivable, but we were actually, it was a much more restricted field of speculation. We were just talking about the cognitive systems that, I'm sorry, I hesitate to use the term higher mammals because it's a complete confusion about the nature of evolutionary biology to use such an expression, but just as shorthand, I mean, the obvious examples that come to mind are the great cetaceans, the whales, the dolphins, and so on. And these clearly have very highly evolved systems of representation and communication. I think there wouldn't be anybody today who would deny that. They're clearly based on the perception of patterns, particularly of acoustic patterns in nature, very different from those that are involved in the acquisition of human language. We were suggesting there might be some common framework in terms of which one might be able to understand that.
Well, one of the great questions that could be answered by your method is, what are whales for?
Sorry?
What are whales for?
What is whales for?
Well, that's racist, that is.
Here's an early discovery of mine when I first got interested in information. This is a trilogy of books by a man called Tom, and his second book is called Meaning, and the third one is called Beyond Information, I think. And in here, his fundamental idea, the first book is called Information and the Internal Structure of the Universe. It's very similar to what Dr. Rowlands was talking about, and maybe it's a better way to think about the other side of, if you like, energy, matter and information, and form that trilogy which probably releases us from faffing around with too much entropy and different forms of...
But there is huge argument as to what information is.
Exactly. There are many various concepts like the ether that undergone a great deal of... And some people use the term to mean what's we call Shannon information, and it's...
Right.
I would say it's already... There's a whole... well, until recently, I think it's actually dying away slightly.
Mike, you've got a presentation of your own later? Is that right?
Yeah, sorry. No, I'm afraid.
Sorry.
I just want to say on the business about information, it's become a big buzzword in philosophy of physics in the recent past. But it's pretty clear when you look at the stuff that they're coming up with that there is really no, as you just made the point, there is really no agreed definition of information. And the idea that one could build a kind of universal ontology of quantum theory on the basis of the notion of information. No, I mean, this is an idea that's been around, it's in the air in philosophy of physics, and personally I'm very sceptical about it, not least because there are so many conflicting definitions of information out there to start.
Okay.
Can I ask one other thing though? I don't mean to kind of pick current out of the pudding here, because this is whole cloth. I can see all of these ideas interconnected a way they form a very deeply interconnected web. So I don't want to just focus on one topic, but the business about Kondratiev waves, I didn't quite understand the claim. I have a friend who's a very good historian of economics. I understand from him most economists these days are pretty sceptical about the Kondratiev cycle. It's not very much talked about now. It's regarded slightly infra dig, as a subject. Well, so what fashions come and go. But in the original definition, Kondratiev was talking about cycles of essentially technological innovation and the way that they drove troughs and peaks of economic growth. That's more or less the gist of it, isn't it? And he thought he'd identified a cyclicity in this. I mean, is there any evidence at all of anything like this cyclicity? I mean, first of all, at what point in the history of the economy does it kick in? I mean, it obviously wasn't there for a very long time.
The major point of this is it's a cycle, but it's not related to economics. It's something in, if you like, nature itself.
Yeah, but then that's also got to do with Kondratiev, who was writing entirely about the cycle.
It just so happens that the cycle with a 54 years, if you like, time period is called a Kondratiev cycle. Like
it's only in the context of
in this list of 39 statements of data sets, we call that one the Kondratiev.
Oh, I see. So it isn't particularly connected with the subject matter that Kondratiev had in mind. It's
correct.
Oh, I see.
But is that 54 years an interesting number, isn't it? It's almost human lifespan. We're talking about death cycles here, how long it takes an idea to die out and a new set to come in. It's more than a generation, 3 generations.
Well, the actual relationship between these time periods is actually the alpha out of Feigenbaum to the power of something. So whatever it is to make 54, right?
I still don't understand. I'm sorry, I'm totally confused now because I don't understand the claim. I understand what the original idea of the Kondratiev cycle was about and the claim that was made. I mean, what is this? What evidence of this this periodicity in other areas is there? And you say you weren't particularly fixated on the 54 figure. I mean, can you give an example of a Kondratiev cycle that isn't to do with technical innovation or patterns of peaks and troughs?
All of those dots on that parabola, which are called the topic map, they are all, if you like, entities.
Can you remind me? Can you possibly bring that slide back up again?
Well, I'm not sure I could do that. It would be very energetic.
I mean, the great thing here, I'm certainly, this is the criticism that's made of the original Kondratiev cycle, and any extent to extend it in a very general way. I mean, you have to, there's going to be an awful lot of suspicion of curve fitting here, isn't there, to put it mildly.
Introduce some measures.
If the Kondratiev cycle is not about what it was originally intended to be,
whatever form of cycle you use, you can set a boundary to its parameters, and then you can do some certain significance tests on that.
Yes, But in what context? I mean, you know, in the context of what subject matter?
Since 1970, we've seen an increase in frequency of the most common one of economic and financial breakdown. It's not any old pattern. It's
No, but I agree. In which case, that's a very specific subject matter. The one expected explanation for that to come from an understanding.
Well, include the varying frequency to a degree, as long as that parameter is small compared with the data.
Try like the
don't worry, it's okay. Tony's just said something which I think helped me a little bit to understand a bit better what the claim is. That it might, for instance, apply to financial cycles as well as to cycles of technological. But except, of course, that you're saying that it's not a cycle because it's driving, it's being driven, it's accelerating.
Rather convincing increasing frequency. Well, there's ways of fitting that in a model.
Oh, sure.
Because of the education going on overall.
Yes, you were saying it's an increase in frequency, so obviously there's something driving the rate of increase of the crisis. But I would have thought the obvious place to start looking for the explanatory factors there was in the operation of the financial system rather than in some absolutely general...
No, but significance testing allows you to get some idea of it on the outside, so long as you don't fit so many modes that it would include everything.
Well, that's my worry.
Then you've got
That's precisely the worry I have.
But you do that by defining structure and seeing that you're having far fewer resulting parameters than the total.
Yeah, but I think that's a rather crucial first step, which otherwise you can run the risk of the
Gentlemen, this is beginning to fragment in terms of discussion, so perhaps we could move this one on to the pub. But before that, Anton's got an announcement about tomorrow. We're reconvening here 8:30 for the Stephen Fry.
7:30 for Pascal's mystic hexagram, or maybe Brianchon, yeah.
Is that start now?
No, 7:30. So give people time to get a sample or something, so that they'll have an hour and a half to get something to eat or drink or whatever.
Right.
Get back here for 7:30, got an hour, and then 8:30 there's a slide with Stephen Fry ready for tomorrow.
We should thank Michael for his talk.
Yeah.
Okay, just a reminder for tomorrow morning. Somebody is going to pick Leon Conrad up.